there is a wave of change coming affecting SoC success. Your team will either be prepared to ride the wave or be crushed by it. This tsunami is being created by the convergence of forces impinging on SoC teams from different directions.
First of all, we have market pressures. Those market pressures are changing things. They're changing the way that chips are designed. They're changing the amount of time that you actually have to get your product to market. They're changing the dynamics that are driving how you actually differentiate your product. Physics is now more of a problem than ever before. So as we started with market pressures driving design complexity, driving process technology, what we're really talking about here is this spiraling effect. At the end of the day, you have a very warped chip. It's very difficult to design and very difficult to ensure that you're actually going to meet your end customer's needs.
When chip design was easy, we saw the rise of the IP, the intellectual property companies. And that was sort of the idea, is that you just sort of went out into the big IP orchard and you picked all the pieces off the IP tree that you wanted.
And in addition, especially as a couple of the earlier talks talked about, we have the space of interconnect. And I'd like to be very clear about that point. Interconnect is IP. As we know now and can appreciate, it has a profound impact on system performance, and it has to be treated as a first-class design citizen rather than as an afterthought, or you throw a bunch of traditional buses together, cross your fingers and hope that it's going to work in the design. And IP and interconnect have a strong relationship together that needs to be thought about and form part of the design and implementation and verification processes. In addition, there are real design flows, and there's two types of real design flows. Both IP and interconnect-centric design, especially the interconnect being based on IP, they come with well-proven past the implementation. When you configure a Tensilica processor, when you configure a Solistics network, interconnect network, you can get the hardware for that, and in the case of processors, the software tool chain, you can get that literally with a push of a button.
Because what we've done is to look at these forces that are warping your chip design teams, causing them the big headaches, and we've applied approaches in our technology and our solutions that allow us to address these. The fundamental approach there is the notion of getting away from trying to distribute clocks or requiring that you distribute clocks everywhere by using self-timed logic for the communications. Clock isolation, or the ability to encapsulate timing into smaller blocks, is enabled by having the interconnect self-timed such that there's no clock necessary to cross the whole chip. It just flows naturally. So naturally, when we think about how we're going to build a solution that might address the spectrum of applications that you folks have, we have to have a configurable topology that can be adapted readily to whatever the particular system requirements are. And that's what we've done. We have to move up a level of abstraction. It's impossible to think about how you're going to design a system of, 100 million gates, thank you, Mr. Smith, and doing it at the RTL level, or heaven forbid, the gate level. So we do need to move up a level, and that's where the Chain Architect tool, which really allows you to think about your system not at the individual block level, but at the system requirements level. So this is wrapped up in what Steve referred to earlier, ChainWorks, which is a tool suite that delivers those sets of capabilities. Chain Architect is the higher level cockpit, if you will, from which you can specify your system needs, evaluate various architectural choices, and if you're using system level tools such as those from CoWare, you can integrate that in with a model that then be used with your processors and other elements to do that system level modeling. Chain Compiler is the engine underneath that generates the specific implementation for your particular configuration and ties directly in with your standard ESL tool flows or your EDA tool flows, Cadence, Synopsys, Magma, whatever you happen to choose. And then Chain Library is where we encapsulate the self-timed logic, target it to a process technology so that we have that guaranteed path to implementation. The net result is I think we can deliver on the promise of being able to have this executable specification for the interconnect flow all the way down through the tool chain to a predictable result. What that does is it saves you design time and allows you to build and innovate in this SoC space.